Hello everyone. In this video, we will learn how to how to decompose the Gini coefficient. For this purpose, we will need two packages. The first one is the Dynamic. So to download this package, there is two methods. First one is to go to packages and click on install. Type Dynamic. For me, I have already downloaded the packages, so no need to do this again. So you should wait until the package is downloaded. The second one is the read Excel. This package, if you have data in the Excel format, so you will need this package. The same thing, just type read Excel and click on install. So to use this package, just click in Control plus Enter, or you can select this line and click Run. So I will start by loading my data. Here's my data. View data. This is my data. My data is the PIB per capita from 2001 to 2015. This is the PIB, original PIB per capita, and I have 5 sub-regions. To understand this sub-region, I shall show you the map. This is the map. So I have 5 sub-regions. The first sub-region, called sub-region 1, contain the 6 region and the 12 region. In total, I have 12 regions. So what I did is I took the Moroccan region, the 12 Moroccan region, and I have created 5 sub-regions to decompose the Gini, because in Morocco we don't have the sub-region data. For example, this is the 6th region called Casablanca Stat. So to calculate the Gini coefficient of this region, you need a sub-region data. For example, the PIB or the revenue per city or per provincial data. So you need a distribution inside each region. In my case, we don't have this kind of data. So what I did is I created 5 sub-regions, 5 sub-regions. That's can to decompose the Gini coefficient. So the third region 1 contains two regions, the 6 and the 12. The third region 2 contain three regions, the first one, the 12, and the 11 region. So this map, this regional map, I convert this regional map to data. Here we have third region 1, third region 1. The data of the third region 1 and the data of third region 1. Here is the data of third region 1, third region 1. And the data of the third region 2, third region 2, third region 2. Third region 2. In the third region 2, I have region 1, 4, and 11. The data of the region 1 and the data of the region 4 and the data of the region 11 here. I hope this can help you to understand what I'm trying to do here to decompose the Gini coefficient. I will leave all this data, the map, and the pair code that I used down in the description, so you can simulate this study or this simple exercise. For this purpose, I'm using the dynamic packages, decomposition of the income inequality. Here the guide of the package. So I will leave this through down in this description. So this package, you can decompose the Gini coefficient by population subgroup. For my in my case, I have the third region, not subgroup, because I don't have this kind of data. For decomposition on a single variable, the mean log deviation, so you can download this resource or this papers to understand the topic. So the package can decompose the Gini, and you can decompose, for example, the tail index, tail coefficient, or the mean log deviation. Also, you can decompose this, the mean log deviation. And also here I have this paper of the decomposition of regional inequality of Turkey. I see Ailina Bayer. I will leave all this paper down in the description. So the decomposition, the causes of the inequality is very crucial for policymakers, as revealing the importance of the different factors will improve the effectiveness of the macroeconomic policy. We will understand disaggregation of the inequality. Particular factor of inequality will be targeted enhanced with decomposition of the population subgroup. Regional income inequality arises. The general expression of the sum of the inequalities within each group or each region or each zone, economic zone or territorial, and the inequality exists between the groups is written alone. So you have the Gini coefficient, or the total Gini coefficient equals the the within effect plus the between effect and plus another effect called the residual effect. The within effect represents the within group or the within region inequality, which is the weighted sum of the inequality within each subgroup or subregion, and the between effect represents the between group inequality, where the inequality with each individual's income receives the mean income of the subgroup to which this person belongs. I have another paper of the policy impact on inequality, the composition of income inequality by subgroups. As I told, between inequality and within inequality, the within inequality element captures the inequality due to the variability of income within each group. Within each group, it means inside each group or inside each region, while the between inequality captures the inequality due to the variability of the income across different groups. It means between the region or between the group. For example, we took the example of the Europe region. If we want to calculate the decomposition of the Gini Decomposition, we will need the data of each country, and we can do this type of decomposition. Also, the Europe region has what we call the knots. The nomenclature of territorial units for statistics. Inequality index generates a within element, between element, and the residual term. There is the residual term. So I will stop here for this demonstration, and I will not do this. So I will focus on the air analysis. So this is my data. I have 12 regions, and 5 sub-regions. Each sub-region contains a region. The data, this is the data, it's the PIB, the regional PIB, or the regional GDP per capita from 2001 to 2015, and I have the population only from 2004 to 2015. So I will start I started the year 2004. I will call this variable regional decomp. The code or the function that I'm using of this package, dynamic package, is called Gini Decomp. As you see here, Gini Decomp. The description decomposes Gini coefficient into population subgroups or subregion or sub-territorial unit. This function is made by between and within group inequality and an overlap interaction. This overlap interaction term is the residual term. So this is the function Gini Decomp. X, a numeric vector containing at least non-negative element. This is my vector. For example, for the year 2001, this is the vector. This is the vector. As you see, this is the vector. The vector X is that contain the regions and a factor containing the population subgroup Z. And this is Z. I go to the population. This is population. This is the vector Z for the 2004, because I don't have this data from 2001, 2003. So I will focus on the 2004, the year 2004. This is the vector Z, and this is the vector X. So to calculate to decompose Gini coefficient for the 2004, I will need this vector year 2004, year 2004 for the whole region, and I will need also the vector Z with the number of population of each subregion. This is the vector Z. So the regional decompose. This is my function Gini Decomp. This is the function. This is the function that I'm using. And this is the vector X that contains the GDP, the regional GDP per capita, and the vector Z containing the population of the region. So and weight, an optional vector of the weight of the X to be used in the computation of the decomposition should be the decomposition of the Gini coefficient by between and within group inequality. Group origin. In most cases, there is an overlap of the distribution of the both groups. Consequently, is that between and within group inequality doesn't add up to the total Gini coefficient, and in those cases there is an overlap term. Overlap term is the residual effect. Remember this overlap term. There is this overlap term. This is the residual or the overlap term between group. The residual, which is 0, if the subgroup in common range do not overlap. Also referred to an interaction effect called the overlap term, the residual term, or the interaction effect within group. Inequality is calculated by using the Gini coefficient for each subgroup or subregion. Between group inequality by using the Gini coefficient or average of the both subgroups. List with the result. So this is my function that I'm using. A list containing the decomposition Gini total. We will see all this Gini decomposition, Gini Group, and Gini Decomposition in the results. This is the reference if you want to for the demonstration and all this. So this is the vector x. The vector x is for the year 2004. This is the vector for 2004, year 2004, and the vector z. The vector z. This is the vector z. The vector z is the characteristic that's to decompose Gini, the characteristic. For my example, I will decompose Gini coefficient based on this criteria, this subregion 1, subregion 2, 3, and 5. So we start by first year, 2002. So to see the results, this is the result for the 2004 result. We have Gini decomposition. This is the Gini, the total Gini, and the within effect, and the between effect here, and the overlap, the interaction effect. So this Gini, this total Gini equals within effect plus between effect and plus the overlap or the interaction effect. We can use also this code. This is the Gini Group. For each, this is what we call the Gini, the inter-region, the intra-region coefficient. So we have Gini coefficient for the region 1, so region 1, and the Gini region, the Gini coefficient for the region 2, and for region 3, region 4, and 5. And here we have the contribution based on the GDP per capita. For example, the region 1 contributes with 0.0021 in the total GDP. So if we, for the 2004, if we add the GDP for the region, region 1 plus region 2 plus region 3 plus region 4 plus region 5, we will get the total, and the region contributes with this 0.0021 in this total region, in this total GDP. Here, you see this contribution. So, Gini Group. So the first example, we decompose the Gini coefficient for only the year 2004. Now we will decompose the Gini coefficient for the entire data from 2004 to 2015. For this reason, we will use the function apply implemented in R. So I will call this data regional inequality. This is the result of the regional inequality. Apply. What we will apply? We will apply this function. We will apply this function Gini Decomp of the package dynamic. So we will apply this function for the entire data from the column 5. This is the column 5. 1, 2, 3, 4, 5. This is the column 5. This is the column 5. Starts from year 2004 to column 16. This is the column 16. This is the column 16. So we will apply the function Gini Decompose from 2004 to 2015. Column 16. The column 16. So it's the same we have here. So we will run this code. Run. Here we have a list. So to see the result of the decomposition of the Gini coefficient from 2004 to 2015, just here we have a long list. So here we have the Gini decomposition for year 2004. To understand this result, we will use this. So we said that Gini coefficient for the decomposition for year 2004. The result we have the Gini total Gini, this is the total Gini, or the Gini coefficient, and we have the wheel effect between effect and the overlap effect or the interaction effect. So we have the Gini group, the Gini coefficient for each group, for each region. So this the Gini coefficient of the region 1, and this the Gini coefficient of the region 5, and here we have the Gini coefficient of the region 2. We call this the intra-region coefficient effect or intra-effect. And here we have the Gini Contribution, Gini Group contribution. For example, the region So region 1 contributes to the total region with this percent. And the third region 5 contributes with this percent. And this is the mean of the GDP. This is the mean of the GDP. For example, if we add the GDP of this the region 1 plus the region 2 plus until the region 12, we will get this number. This is a group. The mean region, the mean GDP of each region. So for this region 1, if we add for this region, if we add the third region, the GDP, this number, the third region 1 plus the third region 2, we will get this number. And for the third region 5, just to demonstrate this, for the third region 5, this number equals third region 1, 2000, and this third region, this number plus this number, we will get this number. So I hope this help you to understand the results. Now we have the chair groups. The third region 1 contributes to the total GDP by this percent, 16.66, and the third region 5 contributes with this percent to the total GDP. Sorry, not to the total GDP, but to the total Gini coefficient. And here we have the chair income groups. The sub-region 5 contribute to the total GDP with this percent. And the sub-region 1 contribute to the total GDP with this percent. Number case, we have 12 region. Number cases weighted, we have 12 region. Years, number of cases. We have 2 region in the third region 1, and we have 3 region in the third region 2, and we have 2 region in the third region 3, and we have 2 region in the third region 5. Number of cases, same thing. So what we have explained here is just for the year 2004, and here we have from 2004 to 2015. We have also this for the 2005. It's the same interpretation or the same explanation, but the results are different. So it's the same as you see for the 2005. 2005 we have Gini total within Gini, between Gini, and the interaction effect. The same explanation. If you are doing static analysis, you can analyze this data each year apart. But if you are analyzing a kind of dynamic analysis, kind of dynamic analysis, so you will need to group all this data in one simple table. I will show you what I have did. This is all these results. So we have here the Gini Decomposition. We'll start by year 2004. So we have here the Gini total, and this is the Gini total Gini. This is total Gini, and we have the weaving effect for the 2004, for year 2004. This is the weaving effect. It's not the same data. I have changed the data. And the between effect. This is the between effect. This is the between effect. As you see, this is the between effect. And the overlap effect. I didn't use it here because I don't need it. So we have this, the Gini Group for the region 1. This is the Gini Group for the year for the region 1. And the Gini Group for region 2, the Gini Group for region here. And we have contribution in the total Gini for sub-region 1, sub-region 2, sub-region 3, and sub-region 4, and sub-region 5. This is the contribution. Where is the contribution? This is the Gini contribution, which we call the anti-effect. This is the contribution in the total GDP per capita. For example, the region 1 contributes with this percent, 21.13 in the total GDP per capita. So, as I told, if you want to do in a kind of dynamic analysis, so we have here, this is the dynamic analysis from 2004 to 2015. What I have did here is just I took these two effects, the weaving effect and the between effect, and I did this graph. This graph. If you, for this analysis, we have here the between effects from 2004 to 2012. The between effect is greater than the weaving effect. That means that the inequality between the regions or the sub-region is more important than the weaving effect. And this, for the policymaker, this result are very important. For example, for the policymaker, if we have two kinds of of the to do two kind of the policy. We have the policy that concentrates on the reducing inequality between a region. For example, we have a region that have more investment, more human capital, and the other region has less investment, less human capital. So if the between effect is very important, so we should focus on reducing inequality between these two regions. And this analysis is also used for the redistribution for the redistribution of income, and also if the weaving effect is very important, as you see from 2014 to 2015, we have the weaving effect are greater than the between effect. So that means that the inequality inside each this region will become greater than the between this region. So here we have the weaving, the between and the weaving using this kind of graph. And here we have the evolution of the contribution of each third region to the total GDP. As you see, the third region too is contributes more to the total GDP. And here we have the evolution of the contribution of each third region, the Gini, of each third region to the total Gini. As you see, the third region to also contribute more to this inequality. I will leave all this graph and this table down in the description. All this result, I have converted all this result to this table, this mega table for the year from 2004 to 2015. And after that, I use this data, this table, to plot all this graph, this dynamic graphs, and then you can interpret this all this table. I should mention that there is other packages that you can decompose Gini coefficient other than that I used in this video, other than dynamic. For example, there is another package called package read, regional economic analysis toolbox, collection of the model and analysis methods used in regional and urban economics and quantitative economic geography, measures of inequality, regional disparities, and convergence. For this package, you can decompose other coefficients like T, Atkinson, and and the mean log deviation. There is a third package called IC2. That's the package. Inequality. That's the package. Inequality and concentration indices and curves. Here is you can decompose the Atkinson, decomposed by population subgroups, and Atkinson measure of inequality within a vector. You can also decompose generalized entropy and decompose also Gini coefficient. All these three packages use the same logic, gives the same results. I already tried this to compare the results. I use the same engine. So if you like this video, please subscribe, like our video. That's encourage us to publish more videos. So